Okay, so let's talk about solving radicals. Here we've got several problems. Now, first thing I want you to remember, we don't see a radical here in problem 1, but any time you've got an exponent that is some fraction, the denominator is the index of the radical that we're going to have. Your numerator is just going to be the exponent of whatever we see there. So in this case, we're going to change this problem here and simplify it into, this represents the square root, because remember the index is going to be 2, so we don't need to write the 2, just we know that when we're writing a square root, the index is 2. And then it would be x to the power of 1. Which is really just the same as saying square root of x. Okay, but as we notice these fractions, keep those two things in mind, that the denominator is the index, the top is the exponent. All right, in this next problem, first thing I want to do is get my radical alone. So before I can even start solving what's inside the radical, I need to get the radical alone. So I do see that we've got that 3 that is with it, so I am going to divide both sides by 3. We were multiplying the radical by 3, so we will divide by 3 to undo that operation. 3 divided by 3 is 1, leaving us with the square root of 2x. 12 divided by 3 is 4. Now we're ready to deal with the radical. That is a square root. The opposite of a square root is squaring. Okay, or in other words, it was a to the power of 1/2. The opposite of to the power of 1/2 is to the power of 2. So when we do that, when we raise both sides to the power of 2, we're now going to get a 2x, because the square root and the square, they eliminated each other, and then we're left with 4 squared, which is 16. Final step, we had 2 times x, opposite of that is just dividing by 2, and we end up with x is equal to 8. If I want to verify and make sure I'm right before I keep moving on, we can do what is called a check, which means I'm just going to put my number, my answer, into the original equation. So we had 3 square root 2 times x, and I'm going to replace the x with an 8. Now 2 times 8 should be a 16. Square root of 16 is 4, and 3 times 4 is 12. Yeah, I definitely did that right. Okay, and by doing that extra step of just plugging the number in, you can assure that the answer you got is the correct answer. So now we've got to get that alone. Once again, we need our radical alone. So we've got the plus 5. Opposite of that, minus 5 from both sides. And we will have square root 3x is equal to 6. All right, now in order to deal with the square root, we're going to square both sides of that equation. After we do that, we'll have 3x is equal to a 36. Divide both sides by 3, and x is equal to 12. All right, so notice in these next ones, we don't see a radical, but because it's to the power of 1/2, we know that this is going to be a square root. So I'm going to start this one off by just rewriting this as my radical. Okay, and you don't have to rewrite it as a radical. We can leave it in that form. So I'll probably show the thinking both ways in this next problem. All right, so let's get that radical alone. Add a 1 to both sides. We got square root 3x plus 4 is equal to a 5. Now we're ready to square both sides. So 3x plus 4 is equal to 25 minus the 4. So 3x is equal to 21. At that point, we've got our 3x is equal to 21. We would divide both sides by 3, and we get x is equal to 7. Okay? I'm just going to move that kind of out of my way so I can work on the next problem. All right, so this one, it can be rewritten in a radical form. So, and actually before we even do that, let's just get rid of that 2 that's being multiplied. So we'll just divide both sides by 2, leaving us with the x minus 2 to the power of 2/3 is equal to a 25. Now, if we wanted to rewrite that one, we could rewrite it as, now notice on the denominator is a 3, so this would be a cubed root. And we would also have this be x minus 2, and it still had an exponent of squared. So those two are equivalent statements. Now, for our purposes, I actually think dealing with the fraction, I want you to know how it's related to radicals and how to rewrite it as a radical, but I feel dealing with the fraction is actually the easier way to go about this. And I'll show you what I mean. So I'm actually just going to move that a little bit over, because what I am going to do to both sides now is I'm going to raise it to a power. Now, when we had to the power of 1/2, we raised it to the power of 2, and that undid it. Because essentially, when you've got 2 to the power of 2 to the power of 3, the way we deal with this is to multiply the two exponents. So that's equal to 2 to the power of 6. Now, if you've got something like 5 to the power of 2 to the power of 1/2, we multiply those. 2 times 1/2 is just 1. And that's what's been going on with whenever we raised it to the power of 2. What I'm going to do here is I'm going to raise it to the power of 3/2. If I do it to one side, got to do it to the other side. Now, the reason I'm doing that is because 2/3 multiplied by 3/2, notice how all I did was flip the fraction, will give me a 6/6, which is just 1. So I'm going to get that exponent of 1. So after I do that, we'll just have x minus 2 to the power of 1. So we can leave it written like that. Now, 25 to the power of 3/2. Remember that this is square root. So the denominator was a 2, so it's just a square root. And then we'd have 25 to the power of 3. Okay, well, let's simplify that. 1, you can type that into your calculator. 2, we can also do this by hand. We know what the square root of 25 is. It's 5. And then 5 to the power of 3 is going to be 125. So for our final step, let's add the 2 into both sides, and we get x is equal to 127. Okay. All right, so in this next problem, we're going to use that same trick as I just used. Try and be thinking right now about what it is I'm going to do. Oh, well, actually, it's the same problem. So, nope. Let's move on. And let's quickly talk about extraneous solutions. An extraneous solution may satisfy the equations in your work, but it does not make the original equation true. So we might go through the process of solving and finding the value of x, and we might find some that if we do a check on them, they don't actually work. Remember how we did a check earlier and we verified, we got 12 equals 12. That means that number worked. We got a true statement. So it was a solution. But we may get solutions that are extraneous, ones that came from our solving process, but they don't actually make the equation true. We need to check our possible solutions. Okay, so right here, it goes through an example of this. So notice their equation, square root of 17 minus x minus a 3 equals x. So first, they're trying to get the square root alone. So they added a 3 to both sides. Then after that, they squared both sides. Please take note about the way that when they squared both sides, they didn't get an x squared plus a 3 squared. They had to square the x plus 3. That is important, otherwise you won't get the right answer. So then we got this statement, 17 minus x is equal to x squared plus 6x plus 9. Now, in order to solve this, we just want to get all of our variables, all of our constants over on one side so that we can factor. So we added the x to both sides and minused the 17. Okay, and so then that gave us this equation, which we could then factor into x minus 1 and x plus 8, which is going to have two different answers. We know a 1 would work because 1 minus 1 would give a 0. We also know that a negative 8 would satisfy this because negative 8 plus 8 would also equal 0. So we got those two different solutions. Now, as we check both of them, notice how in this one, they plugged in the 1, and over here they plugged in the negative 8. Now, when we plugged in the 1, we got 1 is equal to 1. That's true. That is the solution. However, when we plugged in the negative 8 and we began solving through, we only got 2 is not equal to a negative 8. So we got a false statement. Okay, 2 does not equal negative 8. Therefore, the negative 8 is what we call an extraneous solution. Okay, it is not an actual solution. Solutions make the equation true. Negative 8 did not. So that is why it is an extraneous solution. So in these next problems, we are going to be solving them and then checking for extraneous solutions. Okay, so first over here, I'll square both sides of this. Notice what I'm really doing is squaring just all of it. And then that'll leave me with 5x plus 1 is equal to 4x plus 3. Let's go ahead and get the variable on one side. So I'll minus 4x. And at the same time, since I know I'm going to get my x's over here on the left, let's go ahead and move that 1 as well over to the right. So we're minusing 4x minus 1 from both sides. And now we'll get x over there, and we will get 2 over there. So x equals 2. So now we just want to run a quick check, make sure that actually works. So 5 times 2 plus 1 should be equal to a 4 times 2 plus 3. So that'd be a 10 plus 1 is equal to an 8 plus 3, square root of 11, square root of 11. So yes, true. The only solution we found is a solution. It is not an extraneous solution. So we're good there. In the next one, first, in order to solve, let's get that radical alone. So let's minus 3 from both sides. We will get square root of x squared, which actually, as I look at that now, I feel kind of silly. I should have seen that immediately. Square root of x squared. We do know something about that. We know that the square root of x squared is just x, but don't forget that we are currently solving, and that's a variable. So normally when we say, okay, square root of 5 squared would just be a 5. That's absolutely true. But if I'm doing the square root of x squared and it equals 25, there's actually two solutions to that. Sure, 5 squared, or sorry, I should just make that 5. Because I can put in a 5. 5 squared would be 25. Square root of 25 is 5. But if I put in negative 5, then I would also get negative 5 squared is 25. Square root of 25 is 5. So that would have two solutions of 5. So as I do that, so just keep that math property in mind as we take this next step. Over here, I'm going to now split it into two equations. One, we've got x is equal to x minus 2, but we also have x is equal to a negative x minus 2. We got the plus or minus. So we're going to actually solve two equations here. Now, in one of the equations, as we try to solve for x, we just get that 0 is equal to negative 2. Well, that was a dead end. So that didn't provide any solutions. Over here, x is equal to a negative x plus a 2. And in order to get the x on only one side, let's add the x to both sides. Then we'll get 2x is equal to a negative 2. Divide both sides by 2. And x is equal to a negative 1. If I plug that into my original equation, so negative 1 squared is just 1, square root 1 is 1, 1 plus 3 is 4. Great, so we should get a 4 over here on the left. Over on the right, we do negative 1 plus 1 is a 0. Didn't work either. That was an extraneous solution. So that one, we didn't really find any solutions. Okay, all of our solutions were extraneous. All right, I'm just going to move that over to the side again. All right, in this one, we'll square both sides. 3x is equal to x plus 6. Get your variable on only one side by adding or subtracting it. Divide by the coefficient. And x equals 3. So let's just do a quick check. I'm just going to plug it right up there. So square root of 3 times 3 Well, that should be 9. Square root of 9 is 3. So we know on the left side we'll get a 3. Over on the right side, 3 plus 6 is 9. Square root of 9 is 3. We have a solution. All right, let's get that radical alone first. So x minus 5 is equal to the square root of x plus 7. Now to deal with that square root, let's square both sides. Now squaring both sides of the x minus 5, if you don't remember how to multiply polynomials or remember what squaring means, it just means to multiply it by itself. Remember to just do this multiplication box, and it will help you to organize your work. So what we get from that is an x squared minus 10x plus 25 should be equal to an x plus 7. All right, so now let's just get everything on one side. So let's minus an x minus a 7 from both sides, and we will get x squared minus 11x plus an plus an 18. And that equals 0. So now we want to factor that to find what the possible solutions would be. So I'm just trying to think, what are factors of 18? Things that multiply to give 18, but that will add to give an 11. Well, 9 and 2. So this will come out as x minus 9, x minus 2. So the negative 9 and the negative 2 made the positive 18. The negative 2x and the negative 9x would have given us the negative 11, which gives me two solutions, a positive 9 and a positive 2. So we just want to quickly check those. So let's start with the 9. 9 is equal to the square root 9 plus 7 plus 5. So 9 is equal to the square root of 16 plus a 5. 9 is equal to a 4 plus 5. So, yep, that one works. 9 checks out. It is a solution. And let's get rid of that. So now let's check the 2. 2 is equal to the square root of 2 plus 7 plus 5. So that's square root of 9 plus 5. So 2 is equal to a 3 plus 5. 2 does not equal 8. So 2 was extraneous. Okay. In this next one, once again, let's get that radical alone first. So we're going to do a few steps. Let's do a plus 4 to both sides, and let's also minus the x from both sides. Do that in one go, and so we'll have a negative 3 square root x, then over on the other side a negative x and a positive 4. Okay, now usually I would divide here, and that would be perfectly fine, but then I'm going to square, and I'm going to do a square with two fractions in it. I'm actually going to go ahead and perform the square right there. This is going to make things just a little bit nicer. So as I do that, negative 3 times negative 3, we're going to end up with a positive 9, and square root of x squared, 9x, and then I just need to square this side over here, so we'll get x squared minus 8x, and then plus a 16. Okay, so now let's deal with getting it all on one side. 0 is equal to x squared minus a 17x plus a 16, which would then factor into x minus 16, x minus 1. So two potential solutions, 16 and 1. So let's give them a quick check. So we're just rewriting top equation. So a 16 minus 3 square root 16 minus 4 should equal a 0. All right, so 16 minus 3 times 4 minus 4. 16 minus 3 times 4 is 12. Just follow PEMDAS at this point. 16 minus 12 would then be a 4. 4 minus 4 is 0. 0 does equal 0. 16 is definitely a solution. So now we can test the 1. 1 minus 3 square root 1 minus 4 should equal 0. Okay, well, 1 minus 3 times square root of 1 is 1. Do our multiplication. 1 minus 3 times 1 is 3. 1 minus 3 is a negative 2. Negative 6 is equal to 0. 1 was an extraneous solution. All right, so I'm going to stop the video there. I hope this helps with the homework. Good luck.